A long time ago, in an engineering project far, far away, I had occasion to help on some death ray designs. Unfortunately, the prototype was destroyed by militant protesters, and the two gentlemen running the show had a falling out. But I remain optimistic about future attempts to build death rays and the potential peaceful purposes for people's prosperity. So it's another Sci-Fi Sunday here on Science and Futurism with Isaac Arthur, and I am your aforementioned host, Isaac Arthur. On this show we mostly focus on future technologies under known science, but once a month we like to let our hair down and put our Vulcan ears on and dip a bit deeper into science fiction concepts. Today we'll be looking at the classic death ray, what it is, why you might want it, and if such a thing is possible. Now, as to why you might want it, while a death ray is obviously useful to any supervillain looking to upgrade their toolbox, the thing we always have to keep in mind is that weapons and tools tend to be interchangeable, swords to plowshares and so on. Even variations of death rays that literally just kill someone with no outside damage have peaceful applications, like potentially being able to be calibrated to kill something specific like a virus or microorganism. While the classic giant laser is handy for everything from mining to asteroid defense to energy beaming or pushing spacecraft out the solar systems. Indeed, such things aren't usually called death rays but handy devices, and the big concern is often if they could be repurposed or hijacked to serve as a death ray. So we'll be looking at what might serve in that role and how we might protect against such malign use. Of course, we'll also discuss how to malignly use them. So as we discussed in last month's Sci-Fi Sunday on lightsabers and laser pistols, these sorts of directed energy weapons have a long history in science fiction, but we have two early accounts of them in science. First from Edwin Scott, who claimed he had developed a death ray and tried to sell it to the RAF precursor, the British Air Ministry, a century ago in 1924, for killing humans and bringing down airplanes, but he never demonstrated or produced a working one. The next one is a death beam, and comes from the famous and controversial Nikola Tesla, though he explicitly said it was not a death ray and such a thing wasn't viable, instead preferring teleforce, and this is more along the lines of the electromagnetic cannons we often discuss for rapidly accelerating metal pellets or slugs, such as a mass driver. Again, it specifically was not a death ray, but thanks to the New York Sun and New York Times it got mislabeled as one in 1934, and also as a peace ray. Again, Tesla himself was specifically saying such beams or rays were not possible, and we should use electromagnetically accelerated bullets instead, but it stuck in the public's awareness. Incidentally, the laser, light amplification by stimulated emission of radiation, was first demonstrated in 1958, and Scott and Tesla were discussing this in 1924 and 1934 respectively, and while Einstein raised the basic concept of lasers in 1917 in terms of stimulated emission, that didn't suggest a beam, and it wasn't until 1939 that Valentin Fabrikant even theorized you could use stimulated emission to amplify radiation. This still implied no beam. Again, Tesla called it a teleforce, and it got confused as a death ray, and I've also seen folks confuse it as a precursor to an equivalent of a tractor beam, but it's just a machine gun that runs on electromagnets rather than gunpowder, throwing electromagnetic slugs or pellets out, not energy beams or rays. Prior to that, the notion was that light and energy could be focused in, but no sort of tight beam was even considered. This episode is not on lasers, but the basic notion is that you can hit an atom with a light particle, or a photon, of a specific frequency to make it spit out another one, to stimulate emission of a photon or electromagnetic radiation. You do this between a pair of mirrors, one totally reflective and the other nearly so, and a beam of light will come out of that latter mirror. That's a laser, and we also have the maser, which does this with microwaves rather than visible light, though both are electromagnetic radiation. And we have other chunks of the spectrum you can do this with too, but in general we would just call it an ultraviolet laser or UV laser rather than a UVaser or maybe an I-raser in the case of infrared. Though given that heat rays are a popular option for ray guns, and an infrared laser is a heat ray, a powerful one for vaporizing beams being called an I-raser or E-racer would be apt. We are simplifying the explanation of how lasers work for today, but that's it in a nutshell, and without that approach, you can only focus light and energy in on a spot using the classic mirror and lens approach with a focal length. This has been contemplated as a weapon for a long time, maybe all the way back to Archimedes' time, for using mirrors and lenses to focus sunlight and burn things. However, this requires some very big lenses if you want a focal length able to shoot down airplanes or hit anyone not close enough to throw a rock at. As an example, while the Hubble telescope is not our most powerful lens, it's certainly up there, in both size and literal location, and its focal length is a bit under 60 meters or 200 feet. Hubble certainly looks like a big cannon, but in spite of being able to see across the universe, its lens and mirror system, if reworked for weaponization, would not let you nail even another satellite in orbit of our planet by just shining a bright light at it and letting that be pushed and directed into a ray. Pre-laser, this was how you focused a beam down to be a weapon, just a bigger version of a magnifying lens using sunlight to kill ants. We have a device called the Sun Gun, suggested by Hermann Oberth in 1929. Oberth, also known for the Oberth effect, is one of the founding fathers of rocketry, but in this case his suggested use of the rockets would have been to haul up a 100-meter wide mirror to concentrate sunlight on a spot on Earth. I should note that we do have some methods for producing pretty impressive lenses in space. The low gravity and rotation offer some options for spinning a liquid lens up, for instance, and at the top of the atmosphere, up there in low Earth orbit, the Sun is hitting Earth with 1360 watts per square meter of light in various frequencies, and a 100-meter diameter lens would have 10.7 megawatts of power available to it, which would definitely be lethal and rapidly so if focused into some beam a few meters across. A 1,000-meter wide one would offer 100 times the power, over a gigawatt, delivered down to a tighter spot. The problem, of course, is actually focusing it down that tight. On the other hand, we do have lasers easily capable of keeping a decently tight dot on an object at even larger distances, though they spread out eventually too. Lasers do indeed have a focal length. Now again, this episode is not on lasers, and that's largely because they are not good options for death rays, but when it comes to just pouring energy down on a distant target quickly and accurately, they've got a lot going for them. On the other hand, an upgrade on Oberth's Sun Gun might be a liquid lens stored in compressed form in a stealthy satellite waiting to pop open, spin out a very wide thin lens, and aim it down on someplace. We've contemplated various giant lenses, particularly our Mega Telescopes episode, able to make Oberth's suggested 100-meter concave mirror look like a hand mirror. There's little need for perfection in such a lens, as we're not worried about resolving an image like with a telescope, just pouring light down on some spot, so a cheap, big, and expendable lens works well, and orbital weaponry is ideally expendable because it's easily retaliated against, see our orbital bombardment episode. So a cheap and replaceable giant inflatable or spinnable lens and mirror works nicely as a weapon. Of course, you don't really want such things as weapons because a nuke would work much better, though a Sun Gun has the advantage of speed. A signal to one can presumably have it inflating or spinning up in under a minute and aimed on a target. Still, it's more their use as a hijackable weapon that worries us. It's nice to be able to focus a gigawatt of juice down on some offending installation or city, but day to day it's far nicer to have the ability to focus it down wider on a power collector. Power needs vary by time, season, nation, and household size, but we usually put it about 1000 watts or 1 kilowatt per household. That's less than a square meter of orbital power collection, and a 100-meter wide Oberth Sun Gun would supply about 10,000 households, and a few of the kilometer-wide gigawatt ones would run a major metropolis. Now that is assuming you had a 100% conversion of sunlight in orbit to electricity in a house, which ain't happening, but even a 10% efficiency rating would make this very tempting and is hardly ambitious under known science and engineering. Getting things up to space is expensive, but all the equipment needed for power satellites and receivers down on the ground is simplistic. See our Power Satellites episode for the full details. But in short form, if we could manufacture up in space for anything approaching the cost down here, then supplying Earth with power this way is cheap, abundant, renewable for the next 4 billion years, and is even an upgrade on fusion. Those are your two big hurdles though, getting into orbit cheaply and durably or making it there, and the concern about being used as a sun gun or maser. The intent is to send the power down in microwave format. Microwaves are easier to control than light, and highly efficient to convert to and from sunlight to maser to electricity, but that maser is a potential weapon, and so is the enormous collection of mirrors used to gather the light into the power production on the satellite, making the microwave beam. They can probably be turned into a crude sun gun. Now before we get into preventing that, let me just note that even if we couldn't, this is hardly a super weapon. Anything in orbit is easily wrecked during a counterattack, and a giant thin mirror reflecting the sun isn't exactly hard to locate and target, given that even an oboe sun gun should be naked eye visible when deployed, let alone some massive multi-kilometer power satellite array. They are also nowhere near nuclear weapons in destructive potential. A big kilometer-wide array can presumably focus a whole gigawatt down on a place, but that means it needs 4 seconds to release the equivalent of a ton of TNT in damage, whereas even small nukes are measured in kilotons or thousands of tons of TNT, and a megaton nuclear device would represent something like a month worth of energy release by such a beam. Which isn't to imply it's weak, except in comparison to a nuclear bomb. Again, it is releasing more energy each second than several large artillery shells going off. However, it does have to be compared to a nuclear bomb, because folks able to build big orbital power satellites can build nukes too. Now for hijacking one, it's not going to happen in seconds, and it isn't going to result in cities being razed, but one hijacked to be used as a sun gun might be able to wreck a lot of buildings in a few minutes, between seizing control and getting shot with intent to destroy. Though you could also have beams redirected at it meant to just shove it off focus, which we might permit to be fairly automated, since an unfocused pushing beam under computer control is less worrisome than a primary weapon. Barring that, it could do some real damage before being destroyed, but nothing cataclysmic, and again, this is assuming some sort of setup that lets them decently focus the beam too. The Maser is a different story, as it's already designed with focus in mind, but the thing is it's designed to focus to a specific amount, and there's no reason you'd design it to have an ability to focus much tighter. It should have a range of focal length so they can beam down to a receiver station a few hundred kilometers directly below it, or one off at an angle and maybe a few thousand kilometers, but it's not going to be built to focus more than a kilowatt per square meter, and that's not going to do much damage. Microwaves are those things that heat our food up in the microwave oven, but they're also what we use for Wi-Fi signals and radar because they are absorbed by so few things, including air. Your microwave oven is built out of materials that are reflected to microwaves to make them bounce over and over till some food inside absorbs them. A crack in a microwave that lets it leak, which usually run at about a kilowatt, is not going to kill you. Though it isn't super safe either, it still means these masers from above are vastly less dangerous than other routine forms of power we already use. And you can't just jury-rig one to focus some kilometer-wide power beam into some meter-wide death ray any more than you can jury-rig a pair of binoculars and a flashlight into some laser rifle. Building a focusing apparatus for some device is hard and expensive, and harder and more expensive the tighter the focus you want, so you don't casually build in more focus than you need into a power beaming satellite, given that it's spending a ton of money for no better benefit than needing to worry it could be hijacked as a weapon now. This doesn't mean it isn't a good weapon. A powerful microwave signal beamed at a city is going to play crazy with communications there and shoot sparks all over, but it's no death ray. What is? Well, we mentioned nuclear bombs, and we have some beam options for those too, and we also have some sonic weapons to consider. Let's consider neutrons for a moment though. Neutrons are the wrecking ball when it comes to radiation damaging organic life, which is ironic given that they make up the majority of mass in your body. They are slightly heavier than protons, and with the exception of hydrogen, every atom has equal or more neutrons than protons. Yet when one escapes an atomic nucleus, they are highly unstable and short-lived, having a half-life of about 12 minutes. They smash up any complex molecule they hit, including DNA, and they make a wonderful weapon, hence the neutron bomb. Not a beam or ray weapon though, and hard to turn into a beam given that they are electrically neutral. Can we make a bunch of neutrons and aim that at something? Potentially yes, but while we have neutron beams nowadays, they are essentially made by surrounding a neutron-emitting source with some shell and poking a hole in it so neutrons can exit. Neutrons, unlike neutrinos, interact with basically all matter and nothing really bounces them backward, nor does a magnet impact them much since they are electrically neutral. If you could control and focus them as a beam though, then yes, this would be a brutally effective and deadly weapon that would hardly be gentle on inanimate objects, but would be particularly lethal to living matter and complex devices. Needless to say, charged particle beams of protons would be a decent death rate too, but hard to keep focused and dense since protons would repel each other. Same for electron beams, and antimatter beams make a good weapon option too. But a neutron beam, if you can make one, has more of a death ray effect. The rationale behind the neutron bomb was that it would kill your enemies but leave the infrastructure more intact, and the neutrons only have a half-life of 12 minutes, so that part of the radiation disappears fairly quickly, though it's hardly a clean bomb either. It's basically a normal bomb dialed low on yield to allow lots of neutrons to escape rather than enhance explosive yield in a fusion bomb, and a neutron beam, if you could make one, would again be terribly devastating to living material for the same reason, but presumably leave no significant radiation behind. Of all of our options under known science, I'd say a controlled neutron beam would be the lead candidate for a genuine death ray, but it would realistically require either material specifically reflective to neutrons or a field able to turn them, akin to how a proton or electron can be turned by an electromagnetic field. The former implies a potential armor hardened against neutron beams, the latter a potential shield. I'm only aware of one major fictional setting with a neutron laser, Warhammer 40,000, and they're quite right to eyeball these as nasty devices if you got the tech to use them. On the subject of atomic bombs and beams, we do have something called a bomb-pumped laser, and these would be familiar to folks who are fans of David Weber's Honor Harrington novels, where they're called laser warheads. This method is surprisingly straightforward and was developed in Project Excalibur as an X-ray laser that would be a tube lined with uranium-235 filled with a lazy medium, helium and argon were often suggested, and a bomb goes off to supply the huge and rapid energy input, causing a very powerful X-ray or gamma-ray beam to fire in a chosen direction. The first successful test was back in 1980, a couple months after I was born, but it didn't get too much experimentation as the 80s saw curtailment of nuclear weapon research. They've been contemplated for more than just weapons though, and indeed even as a weapon it was viewed as mostly of interest for ABM applications, blowing up ICBMs carrying nuclear warheads, using it to propel a ship being pushed by the laser, or using the smaller, non-bomb pumped types driven just by a nuclear reactor for things like deep cut welding or cutting materials has also been suggested. Needless to say, a bomb-pumped laser is a stupidly powerful one, though by definition a single-use weapon since the bomb incinerates the mechanism nanoseconds after it fires, which makes mounting them in a missile for deployment an interesting option, letting you shoot your laser from a different angle at a target. We'll contemplate an even bigger laser power source in a moment, but let's consider a death ray not based on electromagnetic energy or radiation. Sonic and ultrasonic weapons have often been suggested, indeed they've been developed and used too, and much like light waves, sound waves are subject to being focused on a target. What's more, we have developed the thermoacoustic laser or SASER, the sound wave equivalent of a laser. Simple sonic weapons like loud or frightening booms have a long history, but we also have devices like LRAD, the long-range acoustic device, which is a type of sound cannon, and LRAD has seen extensive use in the last couple of decades as both a sound weapon and a notification system. It makes a megaphone sound like a stage whisper. Now, sound weapons can be deadly, but are mostly of interest as non-lethal weapons, not as sonic death rays. However, extra-aural effects, that is ones not related to hearing, of various sonic weapons appears to include central nervous system effects, muscle contraction, effects on chest and lungs, and hypothermia strangely enough. Testing and documentation of all of the above is limited and disputed to various degrees. The other thing sound weapons tend to be contemplated for is the exact opposite of a death ray, blasts of sound designed to shatter ultra-hard substances without damaging things around them. And while this isn't what we consider a death ray, it does raise a point. For those familiar with the Dungeons & Dragons games, a long-time popular and powerful spell is the prismatic spray or ray, which is actually 7 beams of differing colors and causes different types of damage with each, one being fire, another acid, electricity, and poison, with the other 3 effects including being torn to stone, driven insane, or banished to another plane of existence. I raise it in this case from the last option, which is where someone gets hit by 2 of the beams at once, and of course ideally such a weapon should hit someone with all 7 effects at once, and a really good weapon might incorporate several effects, so that something designed to be immune to or hardened against one effect still gets swatted by the others. Strategically, this is valid too. You don't nuke a planet, you drop biological and chemical weapons all over it, then nuke it, then send in hunter-killer drones to find the survivors, then you virus bomb it and nuke it again. Get the job done, no half measures, but a death ray might be something conceptually along those lines. You torch someone with a particle beam, a neutron beam, a superhot plasma beam, laser beam, and then a string of micro-sized metal pellets electromagnetically accelerated to high speed, which might also include tiny metal tubes or ampules full of viruses or nanomachinery to finish the job up. We're starting up a series on galactic domination this upcoming week, and a critical aspect to taking over a galaxy is being ready to deal with all sorts of insane superweapons the enemy might have. And this sort of over-the-top approach to planetary bombardment or prismatic spray weapons might come in handy. So does sheer power too, and Death Ray could just indicate a conventional weapon dialed up to 11 like the Stellaser, the sun-powered pushing lasers we often contemplate driving spacecraft out to the stars with, or the Nyko-Dyson beam, which is where you convert a star into a single enormous laser. But these shouldn't be assumed to be as big as it gets, and concepts like the bomb-pumped laser work just fine if that bomb is a supernova, or if you're using a neutron star or black hole to generate your X-ray beams or gamma rays. Big focused-in versions of gamma ray bursts or running the power system for some other type of death ray. Sometimes quantity has a quality all its own, and as we like to say on the show, if brute force isn't working, you're just not using enough of it. But setting off a supernova to bomb pump a laser is the kind of brute force you should only be needing for killing gods, galaxies, or Lovecraftian horrors, which to be fair might be the sorts of things you run into out in the universe and need to handle. We spent a fair amount of time today talking about satellites and putting weapons into space, and there's a great episode on the militarization of space over on CuriosityStream if you'd like to know more about the current endeavors and worries, as well as the history of weapons platforms in orbit. As I mentioned near the start of the show, today's episode was a follow-up of our conversation last month on laser pistols, lightsabers, and other common sci-fi weapons, as I felt it deserved more than a quick aside in that episode. And after that episode came out, folks asked about certain types of weapons that killed them in the past or entirely erased someone from history, essentially temporal weapons, and that struck me as something that might qualify as a death ray. So we'll discuss that notion briefly in the extended edition of today's episode over on Nebula. Nebula is our rapidly growing streaming service where you can see all our episodes ad and sponsor free and a couple days early, as well as some bonus content like our extended editions or Nebula exclusives like our Coexistence with Aliens series. You can also see tons of content from many other amazing creators and help support this show while you're at it. Now you can subscribe to Nebula all by itself, but we have partnered up with CuriosityStream, the home of thousands of great educational videos, to offer Nebula for free as a bonus if you sign up for CuriosityStream using the link in our episode description. That lets you see content like the militarization of space, and watch all the other amazing content on CuriosityStream, and also all the great content over on Nebula from myself and many others, and you can get all of that for less than $15 by using the link in the episode's description. Incidentally, I'm sure many of you noticed that today's soundtrack came from the video game Stellaris from Paradox Interactive, and we use it fairly often, and I want to give them a quick shout out for letting us do so, and for the endless hours of good games down the years. I've played a lot of 4X video games, and setting up space empires or achieving galactic domination is a great way to spend an afternoon. And next Thursday, we'll be having the first episode of our new series, Galactic Domination, Empire Eternal, and episode 2 a few weeks later will look at strip mining the galaxy. But before that, we'll examine brain-computer interfaces. Then we'll start July off with a long requested return to our faster-than-light